Welcome to The Explainer. Okay, today we are diving into something truly mind-bending. We're going to explore how a totally dormant 30-year-old internet protocol has suddenly been revived to do something it was, honestly, never meant to do. Orchestrate physical reality for autonomous AI agents. We're looking directly at dossier number 18 to figure out exactly how abstract digital truth is now literally commanding physical machines.
So, here's our roadmap for understanding this massive transition from human commerce to a deterministic machine economy. We'll hit 1. Escaping the Ricardian Trap. 2. The HTTP 402 revival. 3. ERC 7827 JSON ledgers. 4. The Polycritus protocol. And finally, 5. The semiotic bridge. Let's get right into it.
Section 1. Escaping the Ricardian Trap and the payment hash fallacy. To really understand this breakthrough, we first have to look at the impenetrable wall engineers hit when trying to build direct on-chain payment protocols. For years, engineers were trying to bind these bloated, text-heavy legal agreements, what we call Ricardian contracts, directly to digital value transfers. But the core problem here is the payment hash fallacy. Traditional blockchain systems rely on this really clunky handshake. A client makes a transaction, gets a hash, and hands that hash to the server as proof. But this creates what architectural docs call a temporal fracture. The server basically just has to sit there, wait for settlement, and verify an external, totally ephemeral hash that's completely disconnected from the application's actual internal state. It's a massive, massive roadblock for high-speed computing.
So, we needed a complete paradigm shift because we're moving from human commerce to agent commerce. You see, human commerce runs on what we call wet code. It's highly relational, it's inherently ambiguous, and honestly, it's very forgiving, mostly because we humans are forgiving. We use credit cards, monthly subscriptions, we pass KYC or know your customer checks, but autonomous AI agents, they can't exactly hold a piece of plastic or show a passport. They require dry code, absolute, unyielding mathematical rules. For AI to actually act as independent economic units, the web has to shift to strict, micrometered agent commerce driven entirely by autonomous wallets.
Section 2. The HTTP 402 revival. Payment required. To build an infrastructure actually capable of this strict agent commerce, developers had to open up a digital cold case. And it's kind of astonishing when you think about it. Way back in 1996, internet pioneers like Tim Berners-Lee explicitly reserved the HTTP 402 status code for native web transactions. By 1998, it was officially solidified as payment required. So the creators knew we'd eventually need a built-in way to pay for things natively on the web. But then, well, nothing happened. It literally gathered digital dust for almost 3 decades, just because humans don't naturally shop through raw server error codes. It wasn't until autonomous agents showed up that the X402 protocol finally breathed life back into it, taking this ancient legacy placeholder and turning it into a functional, machine-readable API gatekeeper.
To solve this problem, developers adopted what they call the chopsticks design, and the analogy hits the nail on the head. I mean, you wouldn't use a $1 million hyper-complex robotic arm just to pick up a single piece of sushi, right? You just use 2 simple sticks. Similarly, the X402 protocol doesn't drag around a massive monolithic smart contract system full of legal bloat. Instead, it applies a surgical, beautifully simple webhook architecture. This ingeniously simple client callback loop is totally deterministic. Here's how it works. Step 1, an AI agent requests a resource, and the server instantly fires back a 402 status code, demanding payment. Step 2, the agent's wallet steps in, pays a micro amount over the Lightning Network, and signs a cryptographic proof. They often use what's called a macaroon token for this, which acts kind of like a highly secure digital receipt. Then, step 3, the agent just retries the exact same HTTP request, hands over the receipt, and boom, the server instantly unlocks the resource. This allows an AI agent to securely authorize and execute in literally milliseconds, with 0 human intervention.
Moving on to Section 3, ERC 7827 JSON ledgers, value version control. Now, securing the network connection with webhooks, that's really only half the battle. To escape the Ricardian trap completely, we still need an immutable state layer to anchor this digital truth. You see, standard JSON is just a lightweight, stateless format we use to zip text across the web. It's floating. It has absolutely no permanence. But the ERC 787 protocol takes that standard JSON and transforms it into a rigorous mathematical smart contract layer. It introduces value version control. This creates an anchored root-to-leaf architecture that gives you bit-perfect tracking of state transitions, all while keeping the whole thing completely human-readable.
And the absolute engine powering this entire protocol is the LIFO state tree. That stands for last in, first out. By strictly pivoting away from those old floating data structures to a LIFO architecture, the very last item to go in is always the first item to come out. This unlocks incredibly efficient single-entry bookkeeping. Think about it. You only ever need to query index 0 to get an immediate, flawless mathematical proof of the entire system state. There is zero ambiguity here. It is mathematically true or it isn't.
Section 4. The Polycritus Protocol. Deterministic Execution. Now we finally meet the orchestrator that actually pulls the strings by combining all these new building blocks. And let's be aggressively clear about how this architecture operates. It explicitly separates human desire from machine action. As this really profound quote from Dossier 18 puts it, the human acts as the pilot. We provide the overarching creative intent and the moral mandates. But, and this is absolutely crucial, the human is not sitting at a keyboard clicking a buy button. The Polycritus agent cell, which is a highly disciplined Gemini command line interface orchestrator, steps in as a deterministic scripter. It executes the rigorous computational sweat required to lock that human intent permanently into the digital ledger.
So Polycritus completely bypasses those old clunky handshake models we talked about earlier. Instead, it utilizes what the docs call a forensic strike. It instantly locks in 3 distinct things in one flawless execution. First, identity. This is handled by an ERC 804 cryptographic strike where the client signs a specific session nonce. Second, payment, treated as an X402 webhook authorization. And third, the receipt, which is verified directly against that ERC 7827 JSON ledger right at index 0. The ledger literally is the receipt. We have officially moved from a proof of payment into the agentic reality of a proof of state.
And that brings us to Section 5, the semiotic bridge, moving from digital to physical.
With this rigorous bit-perfect stack securely in place, we can finally burst out of the abstract digital realm. But first, I want to challenge a fundamental assumption here. Do computers actually process meaning? When you ask an AI a really complex question, it intuitively feels like the machine understands the meaning of your words. But, well, this is what researchers call the grand computational illusion. Beneath the surface, machines do not understand your intent at all. They only understand pure physics, resistance, and voltage. A massive amount of modern AI computation relies on lossy, hardware-level approximations. But to physically automate the real world using digital inputs safely, we absolutely cannot rely on a foundation that is basically just guessing. We require absolute, unwavering hardware-level determinism. And here is where all of this collides into reality. Meet the Flow X402 CheerBot. It's a 3D printed collectible desktop shell that houses a Raspberry Pi acting as a localized microhost. But trust me, it isn't just a toy. It's a fully functioning robotic vending machine that acts as the physical switchboard for this entire architecture. The CheerBot just sits on your desk, constantly reading that mathematically pure LIFO JSON state tree we just unpacked. When a verified digital tip hits the X402 webhook, the CheerBot reacts instantly. It translates that bit-perfect digital truth into raw electrical signals, sending them straight to its tiny physical GPIO connector pins. For those who don't know, those are simply the hardware interfaces that let a miniature computer talk to and control external electronics. So those metal pins literally shock the bot into action, spinning a motor or dispensing an item right there in your living room.
We have officially built the semiotic bridge. We've traced an incredible journey from a totally dormant 1996 internet status code through the surgical webhooks of X402, down into mathematically pure ERC 7827 LIFO data trees, and all the way to a physical robot executing actions based on absolute digital truth. We're literally tricking rocks into thinking with lightning to perfectly automate our imagination. We're finally leaving the Ricardian traps behind and entering the autonomous machine economy, which leaves us with one final profound question. Now that the bridge between digital truth and physical reality is wide open, what will you program it to do? Thank you so much for joining me for this explainer. Keep learning, keep exploring, and I'll catch you next time.